Dear students and the viewers, welcome back to the part 5 lecture series on lichen economic importance. So continuation of the previous lecture, lichens can also be used in bioweathering processes. They interact very dynamically with minerals which are present on the rocks through bioaccumulation and bioweathering. So what is bioaccumulation? Where you have lichens which can act as a natural sponges and they absorb and concentrate all the minerals, not just them, contaminants also from air and the substrate on which they are present. So this biomonitoring is a process wherein we use these lichens as a map for the atmospheric pollution. Like if you have lead pollution or cadmium pollution, that you can see if they are present in the lichens, then the place is being polluted with lead and the cadmium. And there is a process which is named as biogeochemical prospecting, which can indicate the ore deposits like gold, copper, anywhere underground. And bioweathering is a process where lichens or pioneer organisms that break down the rock into the soil. So that much big rocks, it took millions of years to become soil, and this is made possible, one of the reasons, by these lichens that we refer as a bioweathering process. And not just that, it is also due to physical weathering as well as chemical weathering, where in physical the fungal hyphae penetrate cracks in rocks and piling it apart. Similarly, lichens, they secrete organic acids like oxalic acids, and that dissolve the rock materials slowly. It doesn't happen overnight, but slowly, repeatedly. Then they produce chemicals and they made the rocks. And you can see very clearly the images where these lichens slowly break down the rock and finally into soil. So if the place is highly contaminated, you can see in the background there is much pollution. In those areas, lichens may not be present. They start absorbing, and one point of time they will disappear from the place. So lichens are active geological agents, not just passive surface dwellers. And this is the mind map. One can make use of it. And lichens act as a powerhouse of natural products. Like I said in the previous lecture, usnic acid and atanorin. So these lichens, they possess remarkable chemical in them. As I said earlier, 800 unique compounds are present, and they protect lichens from the UV radiation and also protect them from grazing animals. And they keep the algal partner on check. They will not grow very excessively. So the growth of the algal partner has been kept fixed or to certain conditions, and not too much flourishing growth. And withering of rock surfaces also taking place because of these usnic acid and atanorin. These same properties translate into significant potential for human applications in medical biotechnology also. Usnea produces usnic acid as well as cladonia. So this is usnea and this is cladonia. And paratin, this is from the Xanthoria paraetinia. So a strong antioxidant and anti-proliferating agent, which is researched for their activity against leukemia cells, which you can see here, these two. And gyrophoric acid from Amblicaria lassalia. So this is Amblicaria, and you can see, and atronine from Parmelia and hypogymnia. So this is hypogymnia. And valpunic acid is also been produced from Letharia valpunia. So all these are natural toxins. Sometimes they have some properties of anti-inflammatory and wound healing in some species, like for Parmelia, which is a candidate for skincare creams. So these are some of the lichens which are used in that, in mind map. And in Ayurveda and Siddha medicine also, lichens play a major role. And Shalium, this is referred as Shalium, and Kalpasi is used in Siddha medicines also. In Ayurveda it is referred as Shalium. For cooling, detoxifying, rejuvenating purposes it is being used. And Shyamnaprash, everybody will be knowing about it. So in that also some quantity of this has been added, which treats respiratory issues, chronic fever, and it is a good rejuvenator, which is being marketed in the Siddha and Ayurveda shops. Samruddha Fina, it's a powerful wound healer which is used for burns, ulcers, and respiratory infections, which are due to antimicrobial actions. And you have Charilla. This is also from a lichen which is Cetraria islandica. Island, we call it as Iceland moss, which is soothing demulcent for dry coughs, bronchitis, and digestive troubles. Parmelia, which we refer to as Kalpasi, it's used for cooling purposes and astringent properties also it has got to treat skin diseases and bleeding disorders. So usnic acid has got its own antibiotic effect as well as immunomodulatory role. So in both Ayurveda and Siddha they are being widely used, and these are the mind maps that you can make use of it for easy understanding. So over 800 unique biochemical compounds are present. Usnic acid, a potent antibiotic, and you have Usni plant, which is a wound healing, skin infections for which it is used commercially. And research focuses that there are safer synthetic derivatives like oral toxicity risks are also there, so they have to be very careful with this gyrophoric acid, which even though has got antiviral properties and against HIV and herpes, which is a common disease, these herpes infections, and paratine, which is being extracted for anti-cancer potential, and just induces cancer cells dying after utilizing this. But everything should be done as per the scientific and physician's advice. We are not supposed to take anything as such which may cause severe problems to us. Achonorin, this is anti-inflammatory agent which we have seen already. So they are the blueprint molecules. They have got a great potential to be best products in the pharmaceuticals. Lichens as biodegradation agents. They are master biowitherers that slowly degrade rocks and minerals. When we say rocks, it's not just the rocks but even the statues. So physical action, as I said earlier, the fungal hyphae penetrate. So fungal hyphae penetrate the cracks and tearing it apart as they grow. And the oxalic acid and other acids which they produce, they form soil, and they also release nutrients from that substratum. So when we can use lichens as bioremediation, it may absorb and lock away all the toxic substances which are present in the atmosphere as well as in the soil. If we know all these things, it will be easy for us to go ahead with the heritage conservation. We have lots of heritages which are to be conserved, and for which if we know the functions of lichens, instead of always looking into the positive aspects, if you are concentrating on the other side of it, and if you come to know that they may cause damage to the statues and other things, then we can easily protect them. For conservation, it is very important to protect our monuments, stone monuments. And lichens are nature's slow but powerful sculptures transforming rock into life-sustaining soil. So constantly they will be degrading things on which they are present. Lichens can be the best pollution indicators and biomonitoring. If you have higher density of lichens in a place, then it shows the air is very clean and there is no pollution. If you see the lichens drying up on the substratum, that refers to there are so much pollution, low diversity of lichens, so it refers to the polluted air. You can see at the background you have cities and the trees nearby because of the pollution gets dried up, whereas here in the background you can see a greenery, a forest, maybe a virgin forest or a less invaded forest. You can see diversity of a small quadrant with which they are finding it out, the diversity of the lichens. So high diversity, clean air; low diversity, polluted air. So this is the flow chart of those details. The same You can see rock formation. So bare rock is there and lichen colonization is taking place slowly, not just overnight, but it takes millions of years. Then you can see it has been producing soil, and then slowly the vegetation or plant establishment is taking place. So bare rock, soil, plant and establishment. So this is how it goes. So we can call that colonization, withering, physical and chemical source helping on it, and soil creation, then succession. So succession is where you can see the climax vegetation coming up. So they are the ecosystem engineers. So you may get a question, justify the lichens or ecosystem engineers, or lichens or ecosystem engineers, justify. If a question comes, you have to answer this way. And so this is the mind map of it. It's since a long mind map, I just put it in a slide way so that to learn this. And here, what are the steps involved? Colonization, withering, soil creation and succession. And what are the actions taken by the lichens, and what are the outcomes that has been tabulated. Here you can go through it. So the same here in another different pattern. And nitrogen fixation is also taking place by lichens. When I was dealing in the earlier lecture about the cyanobiome, that means you have a cyanobacteria along with the fungal partner, not the green algae but the cyanobacteria. Example, nostoc. So they can do efficient biological nitrogen fixation. So these lichens present here, they absorb or they convert this atmospheric nitrogen into a usable form like ammonia, acting as a natural fertilizer. So this process is very vital as an ecological service, especially the areas where there is a very poor or barren environment like tundra, rocky terrain, all those areas. So upon death and decomposition of these lichens, also they will release the stored nitrogen, enriching the soil for further plants to grow on it. So when they are alive, they can convert this atmospheric nitrogen into usable ammonia form. Even when they die, whatever the materials that are present in nitrogen, they will be enriching the soil and also other plants. So they are the key pioneers driving ecosystem development and soil fertility. As I said earlier, there will also be a question like lichens or the best drivers of an ecosystem formation, justify, or they develop, they are the basis for the soil formation. If some questions arise, then you have to give all these answers. So what are all the examples of these nitrogen fixation by lichens taking place? The lichen names of them: Peltigera, Lobarira and Colima. So these are all some of the species. This is referred as dog lichen. This is lungwort. We can see all these are here. So this is Peltigera canina. This is referred as dog lichen. And Lobaria. This is Lobaria, lungwort. And this is Colima. So this one is Colima. So see the color of this. It is what to say, like dark color, and this patch is different, and this is also different. Just see this. So decomposition takes place, and the new growth is formed here. And this is the mind map of what I've been telling you. And so far we had been seeing the economic importance, usefulness of lichens. They also have harmful effects, and there are also lichen poisons. What are they, which we will see. So it has got a dual face, two faces. One, they are the lichens are the protectors. The other way, they are the threat for the monuments and the stones which are present there. So they produce potent toxins as defense mechanisms. They can poison, they can damage our organs. If we ingest them, they can even cause death. And biodeterioration is also taking place. They will be deteriorating these monuments, and they can also accumulate heavy metals, poisoning the food chain. If the lichens accumulate lead and cadmium from the air and the soil, and if that has been foraged by the animals, then in the food chain from lichens, this goes into other animals, and it keeps continuing, which is really dangerous. So the safety of the whole ecosystem is questioned in that case. So safety, conservation and ecology is very important, so that we have to understand this to conserve anything on that. So these are all the harmful effects, like toxic secondary metabolites. They can be a defense mechanism for the lichens, but they can cause poisoning, they can cause organ damage, and they are potentially fatal if ingested. And physical damage to the stones, and there will be chemical corrosion of monuments, and they will also absorb heavy metals, and that can be transferred through food chain, which is a dangerous one. Many other organisms that are eating the lichens and which are being eaten by other animals, which all will be getting which are all there in the food chain, will be getting affected. So very important that we should understand all these things, so that we will be able to take the necessary precautions or necessary steps in such case to conserve everything. And what are the toxic lichens? So they are the nature's chemical defenses. You have wolf lichen, which is Letharia vulpina. It contains valpinic acid, which causes liver and nervous system damage. So they are found in the mountainous forests of North America and Europe. And you also have Iceland moss, which we refer that as a Cetraria islandica. It contains succinic acid. As I said earlier, severe stomach irritation and liver damage if unprocessed lichen has been eaten, and edible only after excessive boiling. This is also widespread in northern hemisphere. And you also have another lichen which is referred as ground lichen, Cetraria juniperina, which contains proto-lycosterinic acid, which causes severe poisoning in grazing animals like reindeer, sheep, or whichever is eating that, which is also present in the northern islands and tundra. So you have all these PB, CD, AS that has been absorbed. All these are absorbed here by lichens, and when they grow on monuments, they can also crack them up, and these are bioaccumulated. And when these reindeers eat all those things, then it may pass on to reindeers to humans and other. So that is a very negative effect of this. And this is the mind map of that. And you can see global map of lichen toxins, wolf lichen, and you have it is there in the western northern European Alps, and you also have in other parts of the world. And they cause economic loss, also millions of dollars spent on cleaning and conserving these historic monuments. And the mind map of this. And thank you once again. Please take a notebook and please start reading. As far as the examination as far as the examination is concerned, this particular like an economic importance may be asked in the essay type, or at least in the part C paragraph type question. So you have some 10 or 15 marks in this particular question. So kindly go through it, make a mind map, and don't just stop by making mind map. You start learning this. Learning is very important than getting marks, or we can say both are important. We are, after all of us are here to learn. Keep learning. Thank you.